So you want to do a long division, for example? Chapter 6, section 5, what? 5? 5. 24. Okay. He's got a couple parts to it. This part first. So, when you have something like this, what are you looking for? When you have something like this, what are you looking for? Like terms. I like it. Because when you add, subtract, it's very restrictive. I have to collect all my stuff that are the same. Exactly the same, right? So I have an x here, minus 3x, I put those together. Cool. Negative 2x. So when I'm multiplying, what am I looking for? Like, not like terms. What can I combine up here? What can I put together and why? I'm looking for like sort of like bases. There it is. Right? So for example, these two b's in the middle, I could put them together and make it become what?
Negative 3.
Because what do you do with the powers? You add them. Yeah.
So I thought you didn't add them because it's
The base has to be the same. So, and then the a's you could put together also, right? So the a's, how many a's are there?
Negative 3.
Yeah. And then you can flip both of those down. So real quick, what does this mean? What does that mean?
It's 5x.
Well, that's different.
X times
X times X 5 times. I love it. So if that's X times X times X times X times X, right? What if I wanted to keep going? What if I'm like, all right, I got 5 links in my X chain. I want to have 2 more links. Bless you. Well, bless you. What's linking all my stuff together is multiplication, right? Bless you. It's an exponent analogy, that's bad. So now we got 7. See, I don't need the powers. There's no reason the powers have to be the same. What does a power represent? What does that power represent? The number of these that are linked together. So if we got 5 linked together times 2 more, now we've got 7 linked together. You guys would, I know some of you guys are like, yeah, I know. That's nice for you guys. Just hang back. Look at your favorite wall for a minute. What I'm talking to right now is people that don't get even that. You got to go beyond remembering the rule. Why does it make sense? Then it's not memorization. It's just, I'm going to do what makes sense. Right? A lot of people that are not good at math think that they have to memorize everything. Oh my God, nobody would be good at math if you had to memorize everything. Holy shit, right? So you could memorize this, but I got 5 x's multiplied times 2 more. Of course you got 7 x's now multiplied, right? So I need like bases when I multiply. So over here, can I add these together? Can I add these?
No.
No, because they're not like this has got negative 2x's and this is 2xy's. Could I multiply them?
Yes.
All day.
4x squared.
Negative 4, x squared. Well, I just combine my like bases then, right? So multiplication is always a little less restrictive than addition subtraction. You guys see that? When I add fractions, what do I need? Common denominator. When I multiply fractions, do I need that?
No.
Hell no. 1/15. Done. Yay. So multiplication, division, always a little less restrictive than addition subtraction. Addition subtraction, you always need exactly like terms. Multiplication is kind of like, well, you need like something. They don't all have to be like. You just have to be able to find like bases. Maybe. I don't know. Part B on that 24. Let's see. So this would be the answer there. Oh, this is almost too easy to believe. I'm not trying to make you feel bad if you had trouble with this, but what does that tell you to do? What's that negative power tell you to do? So what's it become then? What's flipping?
1 over
Yeah.
80.
Where's that 1 come from? Well, what's out front? A 1. So these guys go, I'm gone. The ones up there, all alone. Maybe. Yes, sir.
I have a question.
Oh, about up here? Okay.
In review chapter 5, question 81, page 354.
Oh yeah. Okay. Good. So we're at page 354, 81. Ooh, I like it. It's gross. Yes, sir.
What chapter is that?
It's in the review. It's in the review exercise. Yeah. That's why I just said page 350. Can I do anything on the inside? Sort of, but not totally.
Maybe.
Yeah, you could do that. Yeah. So there's two different ways. I could take the 3 down, or I could go ahead. What could I do with this?
Flip 1 over 3 minus 1 by 2.
Yeah, sure. You could do that.
What?
It's a little bit easier to distribute.
What I did inside the parentheses, then I flip it.
All right. So one way to do it. One way to do it
Yeah.
is to take the inside, and what's the only thing you can do on the inside?
Multiply the bases.
Are they like bases?
No.
So you can't put them together. I have
1 over 3.
negative 1 3s and
Okay.
2 2s. I can't
Yeah.
put those together anyway. Right? They just won't go together. But the only thing I can do is negative powers mean flip.
Flip.
So one way to do it,
1 over 3.
yeah.
Right?
And what's 2 squared?
6. 4.
4.
4. Yeah. Then 3
So
over
I simplify the inside first, and then flip it,
So I'm good.
and then
Yeah. Square.
square. I like it. 3 squared.
4 square. 9 over 16.
Yeah, 9 over 16. The other way to do it is to bring this in first. So it'll be 3 negative. What do you do with these powers?
Multiply.
Multiply. So it'll be 3
3. 2.
squared times 2
4.
negative 4.
Uh,
So 3 squared is 9. These 4 2's want to go down. 2 to the 4th is 16. Either way you do it, you get 9 over 16. Those aren't the only 2 ways, but any other way is basically one of those 2 ways.
So the second way is easier, though, it seems like less step.
Yeah. I would agree.
and question 96 is same, right? We need to do.
Yeah, I would do the inside
parentheses.
first, and then I would flip. I would do it this way for when there's a bunch of variables and there's stuff on the top and bottom, I would first work with the inside. This one, the reason I would do this is because this is a straight line. There's no top
no
and bottom.
fraction.
So I would go ahead, because then I would only flip what ends up negative. Here I flipped and then flipped again, you know, so it was extra work I did. But who cares? They're both, you're not going to say, oh my God, look how long this took me. No. This is one step shorter, but who cares? This wasn't that long. Yes?
I have a question.
Oh, Gisela, what was yours?
It was section 5-4. One of the questions, 21, 21. You don't have to do.
Oh, yeah. All right. So I still don't want to do exactly that one for you, because it's the only one out of there I assigned you, right?
I think it's here first, yeah.
Let's do, oh yeah, there were two of them? 21 to 20? 24? All right. So let's do 21.
5-4,
Oh.
So again, I know you can just plug that in the calculator and get the answer.
100 plus 1.
Who cares? Huh? I like it. Good. This is not what the book says I should. I love it. You could all day. And people do, and they suck. Right? This is not about what your calculator can do. Right? Even if the batteries are low, your calculator could still do it. It just won't. It'll be dim. These are both based on what nice whole number?
100.
100.
Minus 1.
101 is
1,
100
plus 1.
Plus 1?
100 minus 1.
So then I get,
Yeah.
what's 100 times 100? 100,
10,000.
100. I just collect all the zeros. My answer is going to have 2 4 zeros. Where am I? Minus 100
100
plus 100.
plus 101. Oh, no, yeah.
Bam. And then minus 1. So what's 10,000 minus 1?
9,999.
I really want you to get this because this is an awesome tool, and I know last time I went to it too quickly. If I wanted to multiply 48 times 22, stay with me. 48 is 50 minus 2. Is that cool? And 22 is
20
plus
plus 2.
now. Let me stop there for a second. Did I change the problem at all?
No.
No, I didn't change it. I made it look different. This is still freaking 48, and this is still 22. And I know some of you guys are like, oh, why the hell I would do that shit, Jeff? And this is just a little tiny sign that algebra actually helps us do stuff, just straight computation in our head. There's no X's or Y's, but the idea I'm using came from algebra. Right? Some of you guys are like, well, then I don't want that. I don't like algebra, so any idea that comes from it sucks. No. Now I can FOIL, right? And math says it doesn't matter how you write the problem, it has to come out to the same answer, right? If you rewrite the problem, it's not going to change the answer. Like, you can't. Otherwise, you rewrote it wrong. So I rewrote the problem, and I can use a different procedure now, but it still has to come out to the same answer because that's the same as that. And what procedure can I use now is awesome. That's a lot easier to multiply 50 and 20.
100. Right? No.
5 times 2 is 10.
1.
Yeah, so it'll be,
Yeah, 0, 0. 1,000.
and then 50 times 2 plus 100.
100.
Negative 2 times 20
40.
minus 40.
4.
Yeah. So then 1,100 minus 40 is, oh, what's 1,000 minus 40?
960.
960 plus 100.
So 900.
1060
Oh, sorry.
1060, yeah. Minus 4.
is 1056.
Now what's 48 times 22? So we have,
1056.
I hope so.
Yes.
Of course. So on one level, it's like you shouldn't be amazed. It shouldn't be amazing. All I did was rewrite 48 in a different way. On another level, you should be amazed. This is easy to do in your head. Maybe not for some of us right now, but it is definitely easier than trying to do this in your head. Can you imagine trying to can you see in your head 48 over 22 line? Let's see now. 8, no, screw that shit. That's horrible. I don't want to do that in my head. That's how I do it on paper. This is how I do it in my head. And this is why I personally don't like a lot of stuff in Common Core. When I say Common Core, do you guys know what that is? If you have kids, you know what it is.
Yes.
Common Core is a kind of new way to package math. Some people don't like Common Core because they don't understand that part of it I like, some of it I hate. Part of it is the fact that who it came from. But part of it is just talking about how to do math in your head. So there are people that are like, no, I was taught to do it like this. This is bullshit. This is bullshit. No, this is how to do it in your head, which is much more important, to be honest. You have to know how to do this. You should. But it's more important to kind of know how to do things in your head.
So like all the people that do the multiplication, they do it that way.
Yeah, this is like the first little trick you learn. The mental math people, are people that devoted huge chunks of their brain to having little tricks like this. And you just keep adding. There's a lot of tricks like this you can use. If you just memorize a whole bunch of tricks, you can be a human calculator. And I'm like, what the hell is the point of that shit? Well, then they make a lot of money appearing on programs, so I can't knock that. Probably make more money than me. Just showing off, I know tricks. Sorry, I don't have much respect for human calculators. I know I can do a lot of stuff in my head, but I don't take time to learn all kinds of shit to do. So I mean, I just know the basic, simple stuff. Yeah.
Can you go over one of the long division ones on 5, 6, so like 27 or any in that section? It doesn't have to be that one. I went to go do it and I looked back at my notes and I just got stuck. I couldn't remember.
All right, let me do it because you were asking about it also. Because what I want to do today is no. You want to? I didn't think so. What I want to do today is focus on every question you guys have, take the quiz, and then leave after the quiz. That's what I want to do. All right, that makes people happy. Yes. So. Yes. Some credits. All right. So, just to re-motivate us, let's remember how to just do this. Once, right? 4 goes into 4 once. So good.
See, okay,
start.
hold on. This is where you confused me to begin with. Because you say you only look at the 4 one time. I look at the actual 41 goes into 48
All right.
one time.
For this problem, I agree. Because it's easy to see that 141 goes into 48.
Okay.
Right?
No, because that's where I kept getting lost. I'm like, I know he said the first number, but
Me?
it doesn't make
I
sense
have-
to me.
When you, what's your first step here?
I have something to tell you. My way to hide all the digits and I leave 79. How 79 divide 2 or divide 23? It's me.
Sure, of course. Yes. So what is your good first guess? Because you're looking at 2370 into 7,984. There's nobody in here that can just do that.
It'd say 12.
Why would you say 3? Tell me, try to really see what your brain is doing.
4 would be too much.
Why?
Because 4 times 2.
4 times 2. 2. And if you're honest, if you really see what your brain's doing, now I know I started off with an easy one, so of course I can see 141 goes in 4. That's obvious. But holy shit, my brain goes, all right, I can handle 2 into 7 is 3. That's what I mean, because when I write this, I only consider this when I'm doing this kind of thing, right?
Yeah.
And students have a problem with that. They're like, no, that's what I do anyway. That's what I do anyway. So the first good guess is a 3, because 3 times 2 is 6. So it should go into that. All right, I like it. Is that, all right. I don't want to do that. Let's go back. I just want to remember the steps of division. Okay. So this is 1. Then 1 times 41 is 41.
7.
Change the sign. 4 into 7. Once. 1 times 41.
35.
And how do I write that?
41.
Okay. So there's the example of just numbers. So when there's variables, it looks worse. It always looks worse. but we do the exact same thing. Because what are variables?
Numbers we don't.
Numbers you don't know yet. So they have to act like numbers because they are numbers. Oh, let's see what you got, Jeff. Let me make something interesting. Right. Yeah. Good Lord.
X.
So again, just like we did here, like 4 into 4 is 1, or like 2 into 7 was 3. So x times what is x squared?
X.
X. I like it. We stop there. Everybody cool so far?
Good.
And then of course, the next thing I did here was I multiplied it by this whole thing and put the answer there. So I multiply this by this whole thing and get,
X squared
Plus 2x.
plus 2.
and then of course I
Just change the.
Change the.
change the sign because I subtract, so I got to change the signs. Stop. What's up?
Okay. I don't get how you got the x first.
Here?
Yeah.
Okay. I shouldn't have erased this one. Blah blah blah. 7, 9, blah blah blah. You with me? How do we get 3?
By times 1, 2 into 7.
Exactly, I like it. So, in fact, another way to say this is 2 times what is about 7? 3. Right?
Yeah.
So x times what is x squared?
X.
Yeah.
I was going to say it. I get it exactly.
I like it. And then you take what you got and you multiply it by this whole thing. Then you subtract, right? And when I subtract expressions, that means change the signs, right? Bless you. That's the part that's harder because it's variables. I got expressions. I got to think a little bit differently, but I still subtract. Well, when I subtract expressions, I change the signs, right? So I'm doing the exact same thing. It just looks different. These go away.
7x.
All right. So now again, same thing here. 4 into 7 was 1. That's what we did. So here, x goes into 7x.
7.
Yeah, or x times what is 7x? It's a better way to think about it. 7. And then 7 times x.
7.
7 times 2.
7.
Change the signs.
Negative 3.
Negative 3 over x plus 2.
So this 35 remainder, who can tell me what that really means? This is weird. Some of you, don't tell me there's 35 left over. That's not good enough. Somebody know what that really means?
Means.
We can divide 41 by 35.
No.
41.
That 35, what does it mean?
It means that there's 35 left over from how many that were evenly divided.
So if I took 35 away from 46, 41 would go in evenly. That's the trick, right?
Mm-hmm.
This tells me how much over or this number is for this to go in evenly. Here, if only this would have been a 14, I would have had no remainder. This minus 3 tells me, oh, this is 3 too small. Make it 3 bigger, and that would have gone in evenly. In fact, what is x plus 2 times x plus 7? You guys see where I'm getting these?
Yeah.
Right? So if I did 41 times 11, here, let's start there. What's 41 times 11? Or you can do the trick.
40.
I mean, I'm not going to do that unless it tells me the book says. You have 400, 40, 10, 1.
451.
451. I like it. And what's 46 minus 35?
451.
451. All right. Now again, that's nothing amazing. That's just realizing what the remainder means. And this is funny for some. I'm sure some of you guys are like, I never was told that shit before. But if you think about it, it only makes sense. That's what it means to have a remainder. 7 goes into 7 once, no remainder. 7 goes into 8 once, remainder 1, because 8's 1 too big for it to go in evenly. It's got that 1 left over. That's all it means. So, same thing. What is x plus 2 times x plus 7 then?
14.
So x squared plus 9x plus 14. How much bigger is this than what I had inside?
Minus 3.
3 big. So if only it would have been 3 bigger, it would have gone in evenly. And now how important is any of that to actually doing any of these problems? Not. But it gives you a fuller understanding of why things work the way they do and what they mean when you get there. And the more you understand that kind of stuff, the less you got to memorize, the more just kind of, I know what to expect, I know what this stuff means. Yeah?
Whenever you're done with that one, I have another.
Oh, okay. Is there any questions on long division?
She was wondering, and I don't know if you have a better way to explain this, so I'm trying to explain it to her, but why the signs changed. So, like, for example, if it would have been x minus 2, it would have been x squared plus 2x.
Signs
right?
always change.
They
Now,
change,
why?
right?
Why?
Why is the question.
Yeah, why is the question? So why? I don't know. Let's see. Help me out. 7 goes into 291. Help me. 4.
Oh, 4.
4 times 7 is 28. Now, if I add these now, if I add these, is that good?
No?
No, I have to change this guy's sign and then add it. Now, of course, you guys are like, no, I just subtracted, Jeff. Subtraction is changing the sign and then adding. That's what subtraction is. There is no subtraction. There's only adding a negative. Right? There is no subtraction. Does that, I don't know if that helps. So when I do this, when I've got this first step on this, when I put the x there and I multiply x squared plus 2x, I then have to, now here's what's really going on, I have to subtract that. Bless you. So what would I do with it negative? I'd have to distribute it. Do I really want to write all that shit down there? No, I just change everybody's sign, because that's what's going to happen. All the signs are going to change because they're going to minus that whole expression. Right? Whereas here, why does it not look as bad? Because that's a number. So I just have to put a negative in front of it. There's only one term. I don't have to distribute a negative anywhere. So then we think of it as subtraction. What we're really doing is changing the sign of the answer I got. 4 times 7 is 28. Change the sign. So then, is that? Change the signs. So it's easier just to change all the signs. So you're right. If that was a minus, that would have been a minus. I would have changed it to a plus. Whatever it is, I change it.
Are we doing 5.5 on the quiz?
Yes. Yes. It could have gone up through 5, 6, but I actually did not put any long division on the quiz.
I was trying to figure out 5.5 on your page, and I couldn't find it. We went up to like 5.4 to mention the scientific notation of 5.5, and then didn't really get too much into the...
Oh, because we talked about negative powers before we even got to 5.5. Because I gave you the whole picture of all the exponents when we first talked about exponents, right? We talked about 0 powers, we talked about negative powers.
Could you go through a couple of these?
Sure.
On 5.5. I was... And I got them fairly right. Like,
Which one?
24, I guess.
We did 24 earlier.
Okay, I haven't done 24. Just any of them.
Here, I'll do 23 because it's like 24. Here,
Segment.
all right. I'll give you a little insight into a possible bonus question on the next test.
Yeah, I'm having problems with the B of it.
No, you're not going to see one of these problems in this section. This is a bonus question. Right? And we'll get back to there in a second. But real quick, I want to make sure you guys understand, just because I make some numbers negative cannot change the property, the process that it is. Processes don't care what's in there. I keep saying that, and I'm hoping eventually you guys will really know what I mean by that. Are the bases the same?
Yes.
So what do I do with the powers? Add them. No matter what the hell they are, you add them. So when I add A to 2A minus B, what do I get?
2A squared
I'm-
minus B.
X.
3a minus 2a.
There it is. 3a minus b. What's a plus 2a?
Oh.
3a. When you add, what changes? Coefficients. Because what do coefficients keep track of? The number of the variables you're adding. I'm not multiplying. I can't change the exponent unless I'm multiplying. So a plus 2a is 3a minus b. What property did I use there? Same way I always use when the powers, the bases are the same. I add the powers. So here, all right, what I just said, does it help with this? Where are the bases the same? Those are the things I could do something with.
X and
X's and
So how many x's total do I have?
negative 3.
Negative 3. There you go. 2 plus negative 5. So 2 minus 5 is negative 3. What about the y's?
3.
Negative 3 plus 6?
3.
Positive 3. Now why is that not quite done?
Because the basis.
You don't stop at negative powers. I like
Oh,
it.
yeah.
So what stays on the top?
Y 3 over
And
X,
these
so
3
yeah.
x's
Down.
want to go down because negative power means flip. So that's the last thing. You don't worry about that till the end. On a problem like this, just make sure there's no negative powers. Just remove those. Anything with a negative power you want to move.
Oh, Mr. Jeff, that's it, because I will lose everything in my brain.
Sorry. So look away.
It's okay.
Yes. I'm sorry, Nate. Do you have a follow-up to this?
Well, actually, that was the easier part for me. I'm having a problem with figuring out what to do with the negative exponent on the outside of the parentheses.
Oh, okay. So part B on this problem, for example, has got, where'd it go? xy to the negative 3. What's the negative power mean?
Flip.